Okay, it's 2 o'clock. I'm going to call the meeting to order. Thanks everyone for being here. Happy New Year. First order of business today is anything additional anyone wants to add to the agenda? Okay, take that as a no. Approval of the previous meeting minutes. You get an approval? First. Do I get a second? Second. Okay, thank you very much. Any board member comments? Okay. Tom, any comments on anything?
The Lakes Committee forwarded to the board their recommendations regarding the e-foil issue. Let's just call it the e-foil issue. The board will be discussing this at next week's work session, and I anticipate a vote at the regular session towards the end of this month.
Okay.
So members those are both public meetings open to the membership, and the membership is encouraged to attend and share their comments with the board of directors.
Okay. Thank you. Rick?
Just a few notes here. Update on the Lake Windsor drawdown. We've been fluctuating between about 46 and 56 inches down, depending on weather. We try to keep up with that the best we can by adjusting the valve. We did add some concrete to the Windsor Dam ramp area. Not the end of the ramp, but there was some caving in of the asphalt at the base of the ramp, and so that's been repaired. We also removed some gravel and silt and stuff adjacent to the culvert that was replaced, so that's been taken care of. And we will close the valve on February the 19th, which is about 3 weeks early this year. If you recall, we began the drawdown early as well, so that's just to keep things the same. The POA Rangers made a little over 1,000 contacts in December, comparable to November, and quite a bit more than December of 2022. Don't know if that was indicative of bad weather in 2022 or not. In grounds maintenance, we do have approval for the replacement of 3 pavilion roofs, and that will take place in the early spring this year. The Avalon heated dock rehab project is well underway. We're replacing the deck boards on that all the way around, and it's not exactly simple because the attachment of those boards is under the walls of the structure, so we have to cut those and knock them out with a hammer, do some jacking of the walls, and so we're about a quarter of the way through with that. Took a little bit to figure out how to do it, but we do have a good process going, and we'll get that finished in the next couple months. We're doing it during bad weather, so it looks like we'll have plenty of time to work. We continue with our normal maintenance, including replacement of dock bumpers and sealing of wooden docks, that kind of thing. We have completed a burn plan for the Loch Lomond Dam, and we plan to burn that sometime in the next 2 months as weather permits, and we're doing that in cooperation with the City of Bella Vista Fire Department, who will be on hand to make sure we don't let things get away from us. Lake cleanup is continuing as well. Between Christmas and New Year's, we had 1,400 rainbow trout stocked in Lake Brittany. That's amounts to a double stocking. We did that in case we have trouble getting our permit in a timely manner for 2024, which we have had issues in the past, not of our doing, but it's just things are just kind of slow. So there are plenty of trout to catch in Lake Brittany. All of our lakes were stocked with channel catfish this past fall, and that's it.
Okay. Any questions? Any questions for Rick before we move on to the next item? Okay, Scott brought to my attention a couple of weeks ago, he had an article about the potential for using what's called the Arkansas Cube, which is a device for encouraging aquatic vegetation growth in our lakes. And thanks for forwarding that article. I thought that was a very interesting deal. And do you have anything to say about that? Because I know Rick and I have talked about it a little bit too. So if you have anything
Yeah,
that
I was just gonna share a quick overview in terms of what the Arkansas Cube is, how it's used, what the potential benefits are, those kinds of things. And this is basically a distillation of the Fish and Game YouTube channel presentation that I shared with everyone in late December. The presentation was put together by Sean Lusk, who's a staff biologist with Game and Fish, and I always say Fish and Game, but close enough. Sean's a fishery biologist with Game and Fish, did his undergrad at Virginia Polytechnic in fisheries science, and I picked up a master's degree at Auburn. His primary research focused on the interactions between largemouth bass, bluegill, and threadfin shad. He's been with Game and Fish for 8 years. 2 as a staff biologist at headquarters, and 6 years in fisheries management based out of Hot Springs. I talked to him by phone yesterday. Recent publications. He did, in March of 23, he did an evaluation of population characteristic differences between largemouth bass and its back cross following a long-term Florida bass stocking effort. And in 2022, he evaluated genetic response following an introduction of Florida largemouth bass into 2 large Arkansas reservoirs. So he's a pretty neat guy. Onto the Arkansas Cube, and according to Sean, this is kind of a grassroots approach to habitat restoration. And why the threat that Sean outlined in his presentation is that there's an ongoing degradation of fish habitat in reservoirs, lakes, and river systems. Game and fish organizations across the country are putting a lot of resources into combating that degradation. But the major obstacle is the scope of work that needs to be done relative to the sheer scale of many of the reservoirs. And a lot of those reservoirs simply are only staffed with 2 or 3 biologists, so you can see the problem. In order to flip this imbalance, approaches are being used to leverage the restoration of fisheries. And one example of this non-traditional approach is what's called the Arkansas Cube. To illustrate what a healthy, viable fishery is, Sean outlined 4 key things. We need the right forage base, both in terms of quantity and quality. We need to have the right genetics in the population pool that are adapted in the environment and have good genetic potential to reach large size fish. Fish longevity, and we need the right habitat. You can look at this kind of as this ideal fishery as a 4-legged stool. You take one of the legs out, stool falls over, and the same thing happens in a fishery. The Arkansas Cube is a habitat restoration and development tool. Habitat in a fishery serves as nurseries for juvenile fish It also provides ambush structure for adult fish like bass, and other game fish. The Arkansas Cube was invented by Game and Fish and the Army Corps of Engineers, their biologist team out of Louisville, Texas. And the Cube is entitled to be a starter device to establish aquatic vegetation. Think of the Cube as a salt shaker or pepper shaker that's placed in the water, and it's packed with aquatic vegetation. And as that aquatic vegetation grows in the water, it delivers seed and other vegetative material to the bottom of the reservoir. That material takes hold, and to use Sean's term, founder colonies of aquatic vegetation are established, and over time those founder colonies propagate and develop more vegetation. The issue with the founder colonies is right now we have a number of grass carp in our lakes, and therein lies the issue, as Rick and his team is well aware of. The cubes are relatively easy to construct. They're 3 feet wide, 3 feet long, and 1.5 feet high. They're manufactured out of PVC pipe and covered with covered sides, bottom, with netting to keep turtles and grass carp and other animals out of the inside of the cube, so they won't eat all the grass. Once the grass is packed, the vegetation is packed in the cubes, the top is sealed off with netting, and the cubes are anchored at spots that within the reservoir system, at spots where traditionally there have been good growth of aquatic vegetation. Once the founder colonies are established, the cubes can be picked up, moved to another part of the lake, and reestablished to create more founder colonies. Moving forward, it'd be nice if we could establish a cube population in 1 or 2 of the POA lakes as a test bed to see how it works. I've talked with Sean, yes, as I said, I talked with Sean yesterday, and he and his team are more than willing to come up to Bella Vista to visit with us, and I have a call scheduled with him next Wednesday to see if we can pencil in some dates and some times when we could all get together, along with the Bella Vista Fly Tyers, who have expressed a big interest in this as well. Thank you.
Thanks, Scott, for bringing that up. And I should have introduced this a little bit better. So we have an issue in a couple of our big lakes, particularly. We've got lack of aquatic vegetation, and we've got too many small fish, along with the grass carp issue. So hopefully, I saw that video and I thought, man, this might be something that we can do. So I'm going to turn it over to Rick, because he's also aware of this, and we've talked a little bit about it.
So a few things, a few cautionary points with what was just spoken about. One is we can have the vegetation in the cubes, but I wouldn't expect any results until we can knock down our grass carp population. But it may be a good idea to keep some vegetation going. I will say this, that the seed bed that is in the lake is probably ample, such that when the grass carp are finally reduced in numbers to where they will allow vegetation to recover, that there's likely enough of a seed base there anyway. And we intend to install some of these cubes and get some things going. Also, I feel like we could fence off some shoreline out into shallower water, and we would get natural vegetation coming on anyway. I think we need to go ahead and do that. I'm also a little bit, I don't want to rush out real fast and build these cubes and bring in vegetation from elsewhere, because you don't know what you might be bringing in along with it. We want the vegetation that was once in the lakes. We got rid of the vegetation because of an invasive species. I'm sorry?
You got rid of the bad stuff.
Yeah, we got rid of that, and so now we need to bring back the good stuff. And there was plenty of good stuff there. And I feel like if we can fence off some shoreline, get some of that good stuff to come back, then we can pull from those areas and seed these cubes. And that way we don't have to go outside of our lakes and risk bringing in something we don't want. Because if we bring in hydrilla or parrot feather again, we're going to start all over with trying to eradicate it, and we don't want to do that. So that's just the one cautionary item that I would say. Coontail's fine.
So do we have enough of these 3 different varieties available that we could go stock some of the, if we do this project?
So the idea would be to fence off some shoreline,
Get it growing?
and get it growing,
And
then seed these cubes with that. I feel pretty confident that
feel like that work?
we have seed base as it is
And basically,
to do that.
just further explanation, when we're talking about fencing off certain areas, you're putting some sort of a netting so that the shallow area.
Probably a hard wire structure.
Okay.
Some sort of fencing material, woven wire fence, something like
That
that.
would prevent grass carp from,
There's a real common 2-inch by 4-inch used to fence off yards and that kind of thing. If we could go to the backs of some of the coves that don't have residents, that would have a problem with it, and fence off some areas, we would see some results and feel pretty confident of.
And there's also some nylon or synthetic fencing. Oftentimes that orange stuff that could be attached to the wire to shrink down those openings to keep the grass carp out. But the first thing is we got to trim down that population.
well, guys, I'm excited. I'm more excited about this than anything I've been in a long time. And so, even if our results are minimal, anything moving in that direction, I think would be a big improvement for our lakes. And so, I know you said the fly tires are behind it.
Well, we're already working with Rick's team on 2 projects right now. In fact, we were at Lowe's on Saturday, and I think we dropped about $800 worth of on materials to get those projects started. We're hoping to have the structures we promised we'd build done by the end of January. So this would supplement those projects, but I think the fly tires would be happy to help build some cubes.
Yeah.
Because they're not hard.
Yeah. Keep us in the loop and go ahead.
And we'll sit down and pick out some coves where we think we can put some of these shoreline structures in, get those going first thing, so that we can seed these cubes.
Okay. Appreciate it.
All right,
Just
thank you.
Keep us in touch. We'll support that for sure. Any questions before we move on about what we just talked about? You call the Arkansas Cube. I don't know if you guys had a chance to watch the video, but if you had a chance, you ought to watch the video. It's really informative. So we're not the only ones with fisheries issues that we're trying to solve. So any other questions? Okay. All right. I'm going to move on, and I think Chris is going to do a SECI data presentation. So I'm going to let him do that. Oh, somebody had a question back here?
How are you going to get rid of the grass carp?
Electrofishing,
Okay.
and I'm not sure how efficient that'll be, but we'll do our best. And over time, they become a lot less efficient in feeding anyway. So given the passage of time, we'll eventually get back to where we can have vegetation even if we don't do anything, because they don't reproduce. But we'll try to help that along as much as we can.
Will Windsor or Loma be one of these two things you're thinking about?
Of putting in the cubes, and as many lakes as we have, as many lakes as we can do, sure. I think we should start off with maybe small scale and then judge the success before we go real big after it. But yeah, the other lakes could benefit too.
Would Lake Ann be appropriate?
It would be. Lake Ann is a lake with its steep shoreline that it there aren't as many natural areas where it would grow anyway.
You're right.
There's a couple though. There's a couple.
But the I guess it would be the north side of the lake has got some coves that would work.
I agree.
What's our top, say our top three vegetation in our lakes?
Well, southern naiad and brittle naiad were the two most abundant native aquatic weeds. Parrot feather was the one that we were trying to get rid of. There were some. So there was a broadleaf pondweed. You may want to jump in and.
The southern naiad and the brittle naiad were by far the most abundant plants in the lakes. As far as the submerged stuff goes, the narrow leaf to broadleaf pondweed, we don't really remember, it was so long ago. It was very small in comparison to the naiad. The naiad probably made up 90% of the vegetation that was in the lake. As far as the submerged vegetation, of course, we have water willow and some cattails around the edges, but the naiad was the most prevalent before the parrots fell. We've never really had all that much coontail in our lakes. It just doesn't do as well in our lakes as the naiad does. So.
Do you know what?
No idea. My specialty is not plants, so.
It just may have. All of our lakes are man-made.
Yeah.
So it may have just not had the opportunity to get established because it was never there.
And the other issue that you run in with this kind of vegetation is that most of the lake surface is not suitable for vegetation at all. Because of the way that our lakes are made, they're flooded ravines. The steep, rocky sides of the bottom of the lake aren't conducive to grow anything. So it's only in a very few areas that you actually have plant growth allowed. For example, Tyree in the back of Lomond is one of the places where we are actually, I think one of our guys is in the process of making upside down Arkansas cubes. So instead of having them float on the surface, we're going to sink them on the bottom and create a cage around the lake bed so that fish can grow. I know Rick mentioned sectioning off pieces of shoreline, but there are some areas that we know have seed beds, if any, and if we can keep the grass carp out of them, that will tell us how well those seed beds are doing. So if we put those upside down Arkansas cubes in the lake bed, we're hoping that we're going to get some vegetation to grow there. So yeah.
So
Just game and fish with their floating cubes. They did their first project down at DeGray, which has very, very, the water levels change a lot, and that was the thought process behind the floating cubes.
Yeah, we're lucky here that our lakes are pretty stable, and the back of Tyree is very shallow, so it has good light And it's always been a place that we've had issues with weeds before. So if anything is going to grow, it's going to be right there. So that's why we want to do those Georgia cube, or upside down Arkansas cube experiments there. And then we can look at transferring, because as Rick said, we don't want to bring anything from the outside in. We've already experienced that and we do not like it.
So what is before we move on, what is the aquatic vegetation that we have growing now in Lowman on some of the shorelines? It's real thick, vines.
Kind of sticky stuff.
Yes.
So that would be the water willow.
And that's good?
Generally, yes. It can be problematic if you want to swim in that area, or you need to back your boat out of your dock and it's in the way.
Or you get your bait in there, but other than
yeah.
that.
So we do control the vegetation in places where it would inhibit boat traffic and recreation. But in general, we leave that stuff alone because it is pretty much the only remaining vegetative habitat that there is.
And it seems to be growing. I'm seeing more of it than I used to in the past. And I don't know if that was on purpose or.
It fluctuates. So when I first got here about 8 years ago, water willow was a really big deal, and we sprayed it quite a lot. And then after about 2 years of that, it just stopped expanding so much, and it's been relatively stable. And only in the last 2 years or so has it started to expand its range again.
Because it's on Brittany also, and you haven't done anything to Brittany.
It's mostly on every lake.
Yeah.
I think I've had one call on Brittany to spray water willow, and maybe one call on Rayburn.
Okay. And is it good fish habitat? Is it
Yeah, it's excellent fish habitat.
Okay. All right. You can move on to your presentation. Sorry, you got sidetracked.
So I'm Chris, and I'm the Lake Ecology and Water Quality Manager under Rick. And today I'm going to go over our SECI volunteer program. But first we're going to start off with a little bit of nutrients so you have some background as to why we even have that program in the first place. So hopefully you remember from biology class that nutrients and energy travel from organism to organism as things eat other things. It can be very simple, like a food chain, but most of the time it's more complex, and we call this a food web. So here's an example of a land-based food web, and this is relatively easy to imagine because we live on land, and so this is more familiar to us. But how does this work in an aquatic environment? Well, there are two major pathways. The first is detritus. So this is generally dead leaves, fallen leaves, but it can also be other dead material. And we have things called shredders that break this material down, which is then consumed by more bugs, and eventually those bugs are eaten by smaller fish, and then all of that is eventually eaten by bigger fish. So the second pathway is the algal pathway. So there are two major types of algae. We have filamentous algae, which is the stringy stuff that you can hold in your hand. It's like a hairball. And then you have planktonic algae, which makes the water green. Filamentous algae is very hard for anything to eat. So the best food here is the planktonic algae. And then we have tiny little bugs in the water column that eat that algae, and then are then eaten themselves by juvenile fish. So as fisheries managers, the planktonic pathway is very important to us. So one way we can help stimulate our lake food webs is by stimulating this primary production, or the growth of that algae. And that happens mostly through photosynthesis. So energy from the sun is used to change carbon dioxide in water into sugar and oxygen. But plants are more than just complex sugars. They're also made up of protein and DNA. And two of the biggest components of protein and DNA are phosphorus and nitrogen, or fertilizer. But we need to be careful not to add too much fertilizer, because too much of a good thing is a bad thing. Nutrients can be both directly and indirectly toxic to aquatic life, and the EPA consistently ranks nutrients as in the top 3 impairments for water bodies across the US. And what we don't want to do is to contribute to species loss and environmental degradation, which leads us into our SECI program. So let me reach around here. The SECI reading is a measure of water clarity. So we take a SECI disk, we lower this down into the water until it's no longer visible. And that is not just a measure of clarity, but it's a measure of productivity, because as I just mentioned, the planktonic algae, what makes the water green, also clouds the water. So when you have more algae, the water clarity is lower. So we have two situations that we have to balance. We have SECI dips that are too deep, which means that it's too clear and it's like a desert. Nothing wants to live there. Then we have the opposite situation where it's too shallow. That means the water's too murky, it's unaesthetic for residents, and it's also potentially impactful for the species and the environment. So we need to be kind of in the middle of those. So once a week, every week, from the beginning of April to the end of September, we have a dedicated group of volunteers that go out and take SECI readings on all of our lakes. So the ideal SECI depth is 2 meters, which is about 6.5 feet. And if it's too far outside of that range, a narrow range of about 0.5 meter one way or the other, we consider fertilizing. And we don't just do that haphazardly. We have a calculation sheet that was made through a scientific study some years ago, and it tells us exactly how much fertilizer to put in to bring the SECI to 2 meters. So let's look at an example graph here. We have our SECI data over time, and you'll notice 2 lines. The blue-green line is the weekly data, and the black line is an average for the month. And on the scale up and down here, we have at the top 0, and down at the bottom 6 meters, which is about 20 feet. And at the top, you have that area where it's too murky, and on the bottom, you have the area where it's too clear. And right there at 2 meters, with the magenta line, we have the target SECI depth. And that little green area is where we would like to see the SECI remain. We also have this vertical blue line, which indicates a fertilization event. And as you can see, when we fertilize, we like to see the SECI decrease. So we are increasing the plankton density and we are decreasing clarity. Now, of course, if the water's too murky, we can't really do anything about that, but we can influence it from when it's too clear. So here we have Ann as the first set. We only had to fertilize Ann 1 time, after which the clarity remained in the target zone. For Avalon, we had to fertilize it twice, and then after which it was very consistent with water clarity. Brittany is one of those lakes that we will pretty much never fertilize because it interferes with our trout stocking efforts. And as a result, it remained very clear from May to mid-July, and then it kind of stabilized on the clearer half of where we would like to see, but it wasn't too far out of range. That didn't update. This point should be up here. But Lomond needed 2 fertilizations, after which the SECI remained pretty stable. Norwood only needed 1 fertilization. Rayburn needed 2. And Windsor also needed 2. So that's all of the data that I have, if anybody has any questions.
I had something to add to this. It's really great that we have a team of volunteers willing to do this for us. and we ask that they do their readings on a Monday. And as you can see, this is a good example of it. We've got fish that hatch in the spring, right? And they're little guys, and they're swimming around looking for food. If there's nothing for them to eat, they die within days. And with our program, when we put fertilizer in the lake, the clarity responds almost immediately. We've got these little animals that reproduce like once every 20 minutes. It's a pretty amazing. And so when there's the nutrients for them to reproduce by, they do reproduce, and then it goes to feed these fish almost immediately. And you can see that in that June fertilization, we got a reading on a Monday, and it looks like by about Tuesday or Wednesday we were fertilizing. And so we're able to make these adjustments almost immediately based on the data that we get. So we're very thankful for the help that we get in collecting the data.
Yes.
Just out of curiosity, these are huge bodies of water. How much fertilizer do you have to put in? Like,
well,
is it truckloads or?
So you say that they're huge bodies of water, but realistically, our lakes are incredibly small. Only Lomond comes close, and only close, to being considered a large body. It's still about 20 or 30 acres below what's on average considered to be a large body of water. So the smaller lakes usually don't require but a couple of bags of fertilizer, a couple of 50-pound bags of nitrogen, and a couple of 20-pound bags, 25-pound bags of phosphorus. Lomond, on the other hand, is quite large. It's just shy of about 500 acres, 470 something, and it requires a number of truckloads. Yes, Windsor requires usually about half as much as that, but oh gosh, I think at one time we probably put 50-pound bags of nitrogen into Lomond, and about 25 pounds of or 25 bags of the 25-pound phosphorus. So
fertilization is the most cost-effective way to manipulate the fish in a system, because you're stimulating the environment to be productive on its own. If we were to stock the fish that would equal what we're doing with fertilization, it would be an order of magnitude more expensive.
It looks like towards the end of the year, you start getting to a point where you have all the lakes in the green zone.
yes,
But during the summertime is when you fall out.
right.
Are the lakes predictable enough that you could preemptively?
Yes and no. So I'm just going to click back through here
okay.
quickly, and there's a couple of points that you should take note of, as Tom noted. In the very beginning, Secchi depths are usually good, and at the very end, usually past July, Secchi depths are pretty good. So there it is, there it is, there it is. It's moved down, but there it is. Same. So the reason that happens is at the beginning, because I don't show the whole year, we're only in the growing season here. So that way you have all of the stuff happening in winter and through spring. And so all those rains and stuff, all that water running over the landscape brings the nutrients from the landscape and puts them into the lake. So we're getting free fertilization every time it rains, you see. But then when you get into the kind of the May through August area is when we tend to have our dry periods, the droughts. That's when that happens. So all of a sudden there's no more nutrients coming in off the landscape. And then when you start to get the rains again, as you get into the more fall-y type periods, and we start to get some even summer showers, we start to have more nutrients in addition to the nutrients that we've already put in. So the spring rains bring the nutrients in. The algae responds. Of course, things grow and die and the nutrients fall to the bottom. And then we have to help it out a little bit. And usually by that point, it's become kind of self-sustaining because towards that end of the year, the water's still really cold. So the algae and the little animals aren't producing as fast because their metabolism is dependent on that temperature. And so when they die, they can't pull the nutrients out of their dead fast enough, and so it tends to fall. But once you get into this portion of the year, in the summer, it's so warm that anything that dies is pretty much immediately remetabolized, and so that those nutrients stay in the water column much longer. Great question.
Also, this past year was usually we have some sort of flood event during the year. We didn't really have that so much this past year, and so we have to be aware of the forecast when we do our fertilizations, because we don't want it all to be washed out just as soon as we put it in.
Right.
But that's really the only thing that prevents us from sticking to a pretty tight schedule.
Does this affect the, obviously it affects the quality of the fisheries, and we're in a situation where we have too many small bass. Does this, by fertilizing, the murkier the water gets, does that help the larger population of bass eat better too?
Yeah, so the more nutrients that you have in the system and the better of a food base that you have, the more everything benefits. So we're at the point where we're putting in the right amount of food, but now we just need to kill back the population. So we're kind of meeting in the middle. We're bringing the food up, now we need to bring the bass down. Because if we were to, for example, stop fertilizing, then everything would just get 10 times worse, because now there's way too many bass and there's exponentially less food per fish. So you would run into a really bad starvation situation there. And the goofy thing about fish is they're weirdly persistent when it comes to lack of food. Like where a lot of other creatures you would think, oh, they're not getting enough food, they'll just die. Fish don't really work that way because they're cold-blooded. They just kind of tend to eat just enough, and they just live on, and they'll be just so emaciated and small. And then coupled with the fact that they have indeterminate growth, which means they'll grow in relation to the amount of food they have. If they're not getting enough, they'll just kind of stay the same size, and so they'll just continue to persist on that little bit amount of food. Like you as a human, I couldn't take you as a baby and then just give you the same little amount of food your whole life. You would not survive, because as you grow, you require more food. But a fish is not like that. It will just stay small and live on that little bit of food.
So is the reason the lakes are so clear at the present moment due to lack of rain? Because I know Loman and Winds are like crystal clear.
Winters are a little bit weird because the rains can be a little bit sporadic. Coupled with the cold temperatures, it makes a situation where the things in the water have a really, really slow metabolism, and so any nutrients that are put in there aren't utilized. So really only once you get back into the spring and the water temperatures warm up is when things can really start to utilize the nutrients that are being put in. So that's why in the winter, you tend to see blue-green algae blooms. So like on Brittany, for example, it's got a bunch of little particulate stuff in it. And it's because there's very little nutrients in the water. There's enough phosphorus, but there's not nearly enough nitrogen. And blue-green algae can take nitrogen from the air. So they all of a sudden outcompete everything else. And so during the winter, it's kind of cloudy and ugly looking, but during the summer they go away because becomes just enough nutrients where the green algae takes over. Only if you want to.
Any other questions from anybody?
I'm not gonna do what.
Anybody else have a question? Sir?
Two questions. When you fertilize fertilize, what is the length of effectiveness or the time, barring, you know, any rain or anything like that to perpetuate it? But is there a set time? I mean, you notice that you did once on some lakes and twice on others. So,
Yeah, I mean, it's as Rick pointed out, it's pretty much immediately effective. So you can see here, each dot on the blue-green line is 1 week apart from Monday to Monday. And so, you know, as Rick pointed out, we got this reading here, and a couple of days later we fertilized, and then the very next Monday, it didn't respond very well. But you can see here on this fertilization, we went from this very low point to way up here all of a sudden. So it's a little dependent on the quality of the water, how warm it is, how much light is getting to any depth at all. But as far as once it's placed and once it establishes itself, I mean, it'll last the whole year. So you can see here, it took a couple of tries, but once we got it going, it just stayed that way. And, you know, most of the lakes are that way. It only required 1 or 2 fertilization events, going the wrong way here, to establish consistency across the...
that's what I was kind of noticing, that, you know, it was kind of like a slow start and then like a big finish.
Yeah,
You know?
yeah.
My other question is regarding our, you know, our forage fish. I guess I'm assuming we still might have a problem with shad that is still too big for most of the fish to eat and still too small, or is that gotten any better? Is that changing, or?
Yeah, so the gizzard shad population is pretty stable, unfortunately. There's not really a big die-off, as I mentioned about the persistency of fish. Shad are particularly good at that. And it helps that we don't really have any big predators yet here. We've already tried to establish some blue catfish, which are more pelagic. So they will, once they get to a big enough size, they grow slower at the start of their life than channel catfish, but blue catfish grow faster after about 4 or 5 years, and they get really big. And they're also pretty voracious predators, not nearly as much as a flathead, but they will go out into the middle and wait in places and ambush shad and chase shad. So we're hoping that that's going to kick in sooner rather than later, because we've already had blue catfish now for 2 or 3 years now. So yeah, they should be getting big enough at this point where they're going to start reducing the shad population.
And that sounds kind of counterintuitive, but what we're looking for is something to kill off some of the larger shad, because they have a compensatory response in that when their numbers are high, they're not in as good a condition. They're not as fat, and so they don't reproduce. So we can go for a couple of years without any reproduction. But if you kill off a bunch of them, the compensatory response is that they reproduce like gangbusters. And then that produces a bunch of small fish, which then can be utilized by the bass.
Now the catch-22 with that is that after one growing season, so if a shad is born in the spring, by the fall, they could be as big as my hand, which is just about too big for even some of our largest largemouth. So they pretty much immediately outgrow the bass population. You know, after one summer, they're pretty much safe from being eaten by a largemouth. Coupled with the fact that largemouth generally don't inhabit the same areas of the lake as the gizzard shad, which is why we need some of these other more pelagic fish.
So you would prefer to have threadfin shad versus gizzards?
Correct, because threadfin don't get nearly as big. Right. But again, shad generally, so Rick just mentioned too far north. There's a lot of truth to that kind of issue with shad. So I've already mentioned the steepness of our lakes. So when you go further south, you have really shallow lakes. You have big lakes that are really shallow, that aren't more than like 10 feet deep. And so basically the whole lake is what's considered a shoreline. Okay, it's shallow enough to where the bass could be anywhere and everywhere, which is why they do so well, and which is why when they're stocked with shad, gizzard, or threadfin, the bass eat them fast enough that they just keep reproducing more small fish, and that's why you have those huge bass fisheries down there. But here in our lakes, we have a very small shoreline in comparison to the area of our lake. Because all of the steep-sidedness, the bass don't like to be out there in the middle of the lake. They like to be next to the shore. But the middle of the lake is where the shad want to be. So you have a separation of habitat. They're in a completely different niche most of the time. It's only in a couple hours during the day, like late at night and early in the morning, they might go to the back and pick at some leaf material in the back of a cove. But for the most part, the shad are out in the middle. So it's kind of like a predator-prey mismatch in terms of who can eat who.
Any other questions for Chris? Thanks, Chris. This has been very enlightening, at least.
I think that's the most questions I've got out of these meetings in a long time.
Anybody else before we move on? All right. So we talked about Sekidator. Any other guests have to make a comment, sir? You want to get up to the mic and give us your name and tell us what you're...
My name's Chris Rose. I live on 7 Bar Lane. I've learned more about fish this afternoon than I ever thought I would. And what I'm going to say isn't so fishy, but I want to go backwards in time a little bit and address something you discussed at your last committee meeting. I wasn't able to attend the e-foil discussion. I'll say right off the bat, I watched the video, I know what you voted, and I know that you've sent the recommendation to the board of directors. So maybe what I'm saying is more for the directors that are here than it is for this committee. But I live where I can see Loch Lomond at the end of the dam. I kayak with a group that we kayak every Tuesday from April to October on a different lake. So and I have a power boat in the marina. So I'm pretty familiar with the congestion and what takes place mainly on Loch Lomond. But with that aspect aside, we anchor off in the coves to go, to swim off the boat. We're not a lakefront property where we live. And my concern now has to do with the 5-mile-an-hour speed limit. And I know that was the recommendation that you're making to the board. I've done some research on the internet, and I was at the boat show last weekend and happened to talk to a dealer from Hot Springs who had half a dozen e-foils there on display. And what question I wanted to ask him was, how slow can you foil on an e-foil? How slow can you go and get above the surface? And what I see on the internet says anywhere from 4 to 8 miles an hour. And I know the speed limit's 5, but I'm not sure that a lake ranger sitting at the no-wake zone buoys would be able to tell the difference between 4 miles an hour and 7 miles an hour just by looking at it without a radar gun.
Well, first of all, the proposal that was brought forth, we were only going to allow e-foils in wake areas. So the 5-mile-an-hour piece really didn't come into play. So really, to operate an e-foil legally, or according to the rules that we put forth, you'd have to be in a wake zone, not a no-wake zone. So the no-wake zone, the no-wake zone was 5 miles an hour or less, but theoretically, you're right. An e-foil, you take between 4 and 8 miles an hour to get up on them. So yeah, they would have to be operated in wake zone and not in no wake zone.
But my concern is, the guys that come in that are e-foilers, they're going to want to e-foil in the no wake zones.
People want to do all kinds of things.
I understand that. And I was young once and I was there. But I didn't see that in what I saw, online on the proposal. And so I don't want to waste you guys' time, but my suggestion or my comment was that you put some more teeth in it and I hope you don't allow them, but if you do allow e-foils, that you not allow them to foil, specifically say that they can't foil in a no-wake zone. Because I didn't see anywhere where it said you can't,
That was part of the proposal.
but I didn't see it. I didn't
Okay,
read
well,
that, so I'm,
Okay, but
sorry
I can
about
tell you,
that.
I can tell you straight up, it was part of the proposal.
Okay, well, that
Yeah.
helps alleviate some of my concerns, so I don't want to waste any more of your time. Thank you
Hey.
for allowing me to comment.
Appreciate your comments. Anybody else, sir? Do you have anything else you want to say? Okay. All right, I don't have anything else on the agenda, so anybody else have any other comments, questions, concern? Oh, we already did that. The minutes from last one? Yeah, we did. Yeah, we did. Anybody else, I'm drawing, Trey, you got anything to say?
All quiet on the marina front.
Okay. I didn't want to leave you out. Sometimes I leave you out, and I didn't want to make sure you didn't have anything to say. So, again, anybody else have any other questions, concerns, comments? Our next meeting is February, second week of February. I don't know the date right off the top of my head, but that'll be our next meeting. Appreciate everyone being here. Meeting adjourned.